Okay, now we're going back a little. Make sure you understand what is a halfway rectifier. And you looking into that, okay? This is a halfway rectified circuit. The input is a sideways here, okay? And now the output, they just a half positive part of the sideway, okay? No negative. So that's why they call a halfway rectifier. You understand the positive part here, okay? Turn on the diode. So that's why you see that they coming out. However, the negative part here, diode will be off. So that's why you didn't see any signal. Okay? On the halfway rectified, first thing is the frequency input and the frequency output will be the same. Okay? And also, they draw this output here without the diode voltage. If the diode voltage is 0.7 volts, so that's why V out will be equal V peak input minus 0.7 volt. Okay?
Okay.
Now, transformer. How come?
I liked what somebody said last week for your lecture, fam, when they said how to figure out if it's forward bias or not is to take it out and then figure out.
You mean for the diode?
Yes. If it's forward bias or not.
Oh,
Or back, or what is it? What's the other? Is it called backward bias? No. What's it called?
Reverse bias.
Huh?
Reverse bias.
Oh,
Forward
reverse.
bias.
Oh, it was you. It was you that mentioned that. Yeah, thank you for saying that because I think that really made it a lot easier for me to understand. So thank you. Thank you for your input.
Yeah. Hey, Mr. Pham, could you put that screen back up that you just had? I had a real quick question.
wait just a minute.
I think his thing was frozen or something.
Yeah, that's what I try to find out.
Yeah.
see, my left.
Did you pay your internet bill, Mr. Pham?
Yeah, that's what I try to see how come what happened to my iPod.
Maybe restart it. Sometimes that's what it needs.
Right,
Yeah.
right.
Or buy something that's not an Apple product.
I'm anti-Apple, but I bowed down and I got an iPad because it was free from my phone company, and it's just so nice, you know. I'm just like, oh my gosh. Uh,
It's when you get the component level repair, you really realize how much Apple is ripping you off because you can actually see the prices for all the components they put in there.
yeah.
And they're not much different than a resistor is a resistor and a diode is a diode. It's not like Apple's using some special resistors from France or something.
Actually, the first iPad I ever got was for my controller on my drone, so I take that back. I have two Apple products, but no phone. No, no Apple phone ever.
The only good Apple is the one you're selling for an inflated price.
Oh goodness. There was something I wanted to. Oh yeah. Fam, I have a comment about what you said, that, obviously you want people to progress in the class. But I do know that this class is open entry and exit. So that means if somebody does take a little bit longer to do the class, as long as they complete the requirements, even if it's longer period of time, they still complete, right?
Right.
Okay. I like that aspect of it because life can get busy sometimes, you know?
As long as you donate to the professor's coffee fund.
Hey, Mr. Pham, did you reboot it?
They boot my iPad.
Did
Yeah.
you do did you do that?
Yeah, I did. Almost done.
Looks like it's time to take out the oscilloscope and the multimeter, see what's going on with it.
Maybe somebody can answer my question. If you on your these because I don't know too much about this stuff on these phones and pads and stuff, if you get rid of as many apps as possible, does that speed up the process or help with the internet or whatever
It won't help with your internet, but it will help with the speed of your
device?
device loading. When you turn it on, you first get in there, start loading. So it's going to be a little faster when you first turn it on. And it might be a little bit faster as you're, depending on how many, if you're talking like oodles and oodles of apps, then yeah, it's going to cause little delays here and there. It's not going to affect anything as far as your internet speed or anything else. It'll just affect, as you're using the app. But sometimes, these cloud-based apps, it's hard to tell what function is being done on your phone and what function is actually being sent to the cloud and being returned back. So it's unless you know the programs really well, it's really hard to tell if it's a problem with the program or if it's a problem with the connection.
And
Okay.
also if it's a phone or, connected to your cell service, right? And you have an unlimited amount, depending on the company that you're going through for that, some of them do throttle. If you use it a lot, they will throttle you.
Okay.
And the last thing on AT&T on the fiber optics is that supposed to be uh up and going all the time? Because like with the cables, they used to cheat you out of your internet
Yeah, I have fiber optics here at the house, and at the time I was working at a job where I needed to have that top speed. I was uploading massive amounts of data, And all of a sudden, my internet was not functioning as it should. So I called them up, let them know what I was doing, and I had 3 guys in here, and they gave me a new modem, and they actually dusted off everything inside on that box that's inside your house. And ever since then, it's just been excellent. So you might want to check your modem. How old is it? They do have new modems. AT&T does have new modems. The guys that come to your house are not supposed to willingly give them up, but if you know that they have them, and I'm telling you right now they do, ask for it. They can't deny you a new modem. Actually, demand it. You're the customer. So
Yeah, I'll check with them. Thank you. Hey, Mr. Pham, so could you go back to that first screen when you very first came up? Yeah, that one right there. Now, can you go over, can you go over just how to like forget about the writing and stuff. Can you go over how to look at this circuit? Because first of all, you talked about pulling the diode out to see whatever, because there's a positive half cycle and there's a negative half cycle. What voltage would you get at the V out at the positive half cycle, and what would you get at the negative half cycle of output voltage?
Okay. I don't know why my pen cannot using it. What's going on?
oh, your pen's not working?
Yeah,
Oh,
it just
darn.
You have to
working
you have to buy all new stuff, Mr. Pham.
Did you fill it with ink?
at 100%.
Hmm. Did you turn it off and on, or can you?
Yeah, I just turn it off and now I turn it on. So that's why I can go to the next one. You see that?
Yeah.
What a thingy, how come?
Well, maybe you can write this stuff on the next page and then show us how this one work on the next page.
Is it wireless or wired?
Uh, wireless.
Wireless? Okay.
So you see my cursor here?
No.
No.
That basically from that
How
guy
long? How long have you had it for?
couple years.
You might be your batteries might be going bad because they like to put cheap batteries in those things. They don't recharge as many times as you'd like.
You would have a connection where you can plug it in the wall.
Yeah, I connect it to the power all the time. It's just working with the pen. Now it's not working.
Do your pointer work like when you're doing something so we can see what you're doing? Do the pointer work?
No,
It doesn't work?
doesn't work.
Hmm. Because that makes it hard for us to tell what you're talking about sometimes when you're not using the pointer.
Yeah.
Okay, so maybe I have to using the PowerPoint. Now you get a question about that one, right? Can you see it?
Yes, we can see it, and I also see your mouse.
Okay.
Is there any way you could make it bigger?
Let's see.
You would stretch it from the bottom? Okay.
So you can see it now, right?
Correct. And what we want to know, Mr. Pham, what would the output look like when you're looking at the positive half cycle, and what would it look like at
Okay,
the
now, when you apply positive, right?
correct?
That means positive here.
Right,
So that turn on the diode.
right. Forward bias.
Yeah, forward bias. So that's why the output, this part here, coming out.
Correct.
Okay? When the negative input in here,
Then the anode is negative.
yeah, they open.
Oh, okay. So it's reverse bias.
Exactly.
And then it clips off the bottom portion of the sine
Right,
wave.
right.
Okay, bingo. So,
Okay?
so, so on one of them, on forward bias, the output is 0.7, correct?
Yeah, if they using the diode with a 0.7, then basically they have to start from here. You see that?
Right.
Minus 0.7.
Mm-hmm.
That's a DC. Okay? However, in here, you understand the frequency input, okay, and the frequency output will be the same, okay? And now if they say, I want to using the second approximation, that means the 0.7 volt for the diode, then V peak out will be equal V peak in minus 0.7, okay?
Was that for what you just said? Now, was that reverse bias or what?
That was forward bias, wasn't
Yeah,
it?
that's forward bias.
Oh, forward bias. I'm sorry.
And so if it were a reverse bias, uh, can you give us the, yeah, we see the lower one is reverse bias. So then what would it look like as far as the outcome of, it would be zero, right?
Right. That means they say VD equals 0 volt.
So
That
if you were to take the diode out to figure that out, and then it
is
would be
zero.
right.
V out 0. Okay? If no diode here, V out will be the 0 volt. So that's why the 0.
And no current goes through the resistor, right?
Yeah.
Okay.
Only thing is, they say if the diode is not 0, 0.7, then V out, peak out will be equal V peak in minus 0.7.
So let's say VN is 10 volts, right? That's V pick, right? That's VP.
Okay, okay,
And then it would be VP of 10 minus 0.7, correct?
exactly.
Okay. I'm still a little iffy on the revert or
Now,
yeah, reverse bias, but
that's forward bias.
right.
That's why
I got
this is,
yeah, I got forward bias down, but I'm just a little iffy on how do I tell if it's a reverse bias.
okay, now,
I know it's zero in the end, but how do I get there?
okay, I can tell you, let's see. If you say we pick,
10 volts.
okay, we pick equal 10, for example,
Okay.
10 volt.
That's 100, Mr. Pham.
Whoops.
There
Okay.
you go.
And also VD equal 0.7. Okay. Not 0. Now, when the diode on for 10 volt, positive, right?
Mm-hmm.
Mm-hmm.
Then the diode on. And I already telling you, when the diode on, you have to substitute diode by the battery. That means you have to substitute diode by the battery.
No matter if you're doing AC or DC?
Doesn't matter. If you say diode on, then now you didn't see any more diode, but you can see battery.
What does that even mean?
10 volts, right?
Just a minute.
What does it mean to substitute it for the battery? You said that a bunch of times, but it's not clear.
I already talking at the beginning, okay? You cannot leave in diode there to solve the problem. First thing you have to decide diode on forward bias or reverse bias. Okay, and now this the value of the diode now. They will be 0.7 volt here. Okay, and this is a positive and this will be a negative. So when the diode forward bias, they look like the wire. Okay, and the voltage will be 0.7 here. So that's why they allow the positive plug here to go to the outside, to the Vout. Okay, and
So,
now if you get a negative plug here, that means minus 10, right? The thing is we pick it 10 volt. And positive 10, negative 10. Okay, that means 5 volt. The thing is we pick right here 10. Okay, and here will be minus 10. Okay, so when the minus 10 in here and the diode revert bias, that means no diode here. Open. So that's why Vout will be 0. And now, if you get the VD 0.7, then this is the battery, positive on this side, negative on this side. Then the output will be at a minus 0.7. Okay? So minus 0.7, this is a 0. I suppose this is a minus 0.7.
So when the battery goes through the
Yeah.
dial becomes 7 volts. Okay, yeah, because I was trying to see where you got that 7 volts, but I see that the battery is 10, so it travels through the dial and it converts to 7. But that kind of makes sense.
So that's why.
So essentially the V pick would have to be a negative number for it to be a reverse bias. Am I getting that correct?
Okay, now, if they revert bias, you don't see any Y here. They open. Revert means open. When they open, that means no current flow. So VR will be 0. When they positive here, you see that? 10 volt. You turn on the diode. And turn on the diode, that means same thing, you get a battery here. For the diode, left side will be positive and the right side will be negative. So that's why at the output you get two type of the voltage. One will be VP. Another one will be minus 0.7 volt. That will be a volt DC.
Oh, I think your pen's working. I just saw a red line.
Professor, quick question on this. What's the most common use of a half wave rectifier? Because obviously certain things don't like pulsing electricity. So where would you use this?
Now, depending on the application, okay, later on, you can try to see is it they using that for something else. However, to the guy, when you're looking into the circuitry, you know this is a half-wave rectifier. Okay? And if you get the input a sine wave, you want to draw the output, okay, of the half-wave. So positive, you can get the signal coming out. Okay? However, the negative here, that means you can get minus 10 volt peak here. This side will be ground. So that's why the diode will be reverse bias. That means open, no current flow. So that's why you can see this signal here.
And where does that 0.7 volts, that line in the blue, where does that come from?
That means at the positive here, okay, you get the diode on, right?
Right.
That means the voltage Vout for the DC, they will be equal minus 0.7. That's supposed to be minus.
Yeah, that's my biggest problem is trying to understand where does the minus 0.7 come from?
Okay, you don't know where the minus 0.7, right?
Yeah, where does it come from?
Could it be other way how the diode looks? Because it has like a line in a
Oh,
triangle, or no?
let's see. I tried.
It's the material that the diode is made out of. It takes 0.7 volts to conduct.
Yeah, and I think the positive and the negative, if you replace a diode with the battery, then the left side is a positive, the right side is a negative, and that's where the negative comes from. Is that correct, Fam?
Yeah, what I'm saying is, okay, if you get the diode only, okay, let's see, I think we already get somehow in here. Okay, now you can see this diode here. Okay,
Can view.
10 volt, V bias. Can you tell me diode on forward bias or reverse bias?
It's
When
okay.
you take the diode out, if you
No,
take the
no, no, no. Don't take the diode out.
It should
There's
be
Get a
there's a
simple.
there's a ground, so it would be 0 on the right side of the diode, right?
Yeah,
it's going to be plus minus plus minus. It's going to be forward bias,
and it'll be on.
and
right.
yeah, it'll be on.
They will be on.
The
Okay.
resistance isn't enough to.
Yeah, they will be on. Now, I already telling you the key point in here. Okay. And you will be get when they on. You substitute the diode by the battery.
What does that mean?
That means in order to do a calculation, you can calculation with the symbol for the diode. That will
Can view.
What he's
Can
saying,
one father.
what Mr. Pham is saying in step one, when you remove the diode, you're determining whether if it's forward bias or reverse bias. Then once you determine that, then you if it's forward bias, you replace the diode with a battery.
That, that doesn't make any sense.
okay.
Replace it with a battery? Like, okay.
Okay. Now, this is a very, very basic, and basically we have to really understand, okay? Otherwise, we get a lot of problem.
This is positive. Positive, positive.
Okay? So when they on, there'll be a lot of problem here. Positive, and the value will be 0.7 volt. Okay, now, when you say the diode forward bias, then forget the diode. You substitute the diode by the battery. this battery will be substitute for the diode. And that will be connect one side to the route. Okay? So forget the diode here. My question is, what V out equal? If you look like the circuitry look like this way, what V out?
Isn't it 10 volts? Oh,
9.3.
Come on.
Oh, wait a minute. Oh, that's right. You replaced the
it's 07.
it's 10 volts, 10 volts.
I thought it was 10 volts, but I think
Come on.
it's 0.7
Right.
because it's the positive side of the battery.
That's what I said. If
Right.
you're using the meter to measure your car battery, what voltage you get?
Oh, that's right. You get 0.7.
Now you measure V out across the 0.7 volt, then you must get 0.7 volt.
Correct, correct.
Okay, now, if the diode revert bias like that one, then what you substitute here with the diode?
Zero.
Zero, correct. However, a little more detail. When you say revert bias, they will be
Like an open switch.
open, right?
Mute.
They will be open here. So that V out will be equal 5 volt here. The thing that they not connect to the route. That only key point for the diode. When you say forward bias, you must substitute diode by 0.7 volt battery. And if you say the diode revert bias or diode off, they will be open. That's it. No current flowing.
Okay. Got you, Mr. Pham. Thank you.
So when the diode is off, it oh gosh, no, I forgot what I was going to say.
Revert bias, right?
Yeah, reverse bias, but also it would be open.
Right. That means off. That revert bias. On, forward bias. Either way you want to say it. You say diode forward bias, that means the on. Or you say the diode revert bias, mean they off. Off means open. That's what I already showed you.
Gotcha. Thank you.
Okay. The thing is otherwise, we get too many problems. They already showed you right here. Forward bias, they connect so the current can be flow. But you substitute the diode by battery, 0.7 volt. If they revert bias, that means they off, okay? Then basically you see that they open. That means no current can be flowing. That's the only thing they want.
So if no current is flowing, that reverse bias one, it's the same as zero, right?
Right. Okay, now, this is only thing I expect when you see the circuitry. They will be halfway. Why halfway? They just rectify only positive. Okay? If they put a diode on the other side, they will be halfway, but they will be rectified negative. Okay, now we're talking about transformer. What is a transformer? Basically, they say transformer 1 voltage to the other. That means they transfer the 1 voltage to the other. You can see outside your house, the voltage outside, they can be a 400 volt. However, when they go into your house, 120, okay, they get a transformer. Transform 1 voltage to the other. Okay, now you can see how they look like. That VP, that means a primary. And the other side, VS, is secondary. Okay, primary voltage VP and a secondary voltage VS and a P. Okay, and P here. Okay, number of turn in primary and NS number of turn in secondary. Okay, winding. They're using the wire. See how many turn you get on primary and how many turn you get for secondary. So they given you the formula NP over NS equal VP over VS. VP means primary voltage. VS is secondary voltage. Okay, and now you say, okay, I want to calculate the VS. Then VS will be equal NS times VP divided to NP. Okay, so they tell you if NS greater than NP, the transformer will be stepped up. I given you example. If you apply, get a voltage here 120 volt, and the output VS secondary 400 volts. That's what they call a step up. Okay, if you get a VP at 240 volt and go output here, you get 120. That will be step down. Okay, depending on NS greater than NP or NP, NS less than NP. Okay. Only thing is when you're looking into the schematic, you recognize it as a transformer. Transformer means transform 1 voltage to the other. Okay? And what is the NP? What is the NS? NP, that means the how many turns, okay, for the primary and how many turns for secondary. You see that? That's just a wire, just a turn, how many turns, okay? If VP higher than VS, that means step down. If VS higher than VP, that means step up. Now, you can see this circuitry the same like the other. You see that? You get a diode, and this is just the load. However, on the other one, on this one, they're using the generator, giving you the sine wave. Okay? On this one, you the same get the sine wave. Okay? However, they're using the transformer. Primary turn NP equal 2, NS equal 1. Okay? So if you get 156 volt at a V peak here, what is the V peak here? That means they get a VP, okay? 156 V peak.
So the VP is 156.
Right. Let's see. If I write down here, can you see that? Okay. VP
Yeah.
equal 156. VP, right?
Mm-hmm.
Okay. And basically, if you're looking into here, you can see you get NP equal what?
2 to 1.
NP equal 2.
Right. And then NS is 1.
Perfect. And that equal 1. So now you get the formula. Okay? This formula we add here.
VS equals NS times VP over VP or NP, sorry.
Yeah, here.
Okay.
Right?
Yep, because we want to find out what VS is.
Exactly.
Okay, gotcha.
So equal and add 1, right?
Yep. One
Ah,
time 1 times 156
okay. You get it.
over 2.
156 over 2
So that'd be 156 divided by 2.
equal what?
Oh gosh, I can't think of it in my head.
156 divided 2.
Yeah, let me
78.
78.
70. Okay, thank you. 78.
Okay. That's why you say, okay, they want primary very big, okay, and they want to be Satan, right?
Yep, and it would be a step down because VS is a lower voltage than the primary of VPIC.
Okay, and now they say the rectified big output, okay, that means the voltage we are right here, what we are supposed to be.
Oh, okay. Let's see.
Would it be 78 minus 0.7?
Okay, perfect. 78 VB
Minus 0.7.
minus 0.7 for the
And,
diode.
and that'll be a output voltage.
Exactly.
Isn't that 70? Would you still call that 78 VP
Right.
instead of 78 VS? No?
VP.
Okay.
Okay. The thing that they given you VP here. You see that? That's 156 for a halfway.
Right.
And you go up, down, peak to peak, you have to multiply by 2. Okay? From top to the bottom.
Gotcha.
Right now, 156 only peak. Okay? So the V output will be 78 volt. Okay? That for the V peak. You minus 0.7. So whatever you get. Okay? They already telling you right here. V peak out equal V peak in minus 0.7. Okay?
And
So,
in this particular case, the V peak in is the 78 volts that's coming into the secondary minus the 0.7.
right. That's only telling you if you draw it, they will be 0, for example. This is 0. So you can have to get a minus 0.7 here. Okay? So basically the V peak not 50, not 78, but the V peak basically equal 78 minus 0.7, 71.
$77.3.
That's 78 minus 0.7. So
Oh.
basically output will be 71 V peak.
Mr. Lamb, how could it be? I thought it was like she said, shouldn't it be 78 minus 0.7 and 78 point minus 0.7? Ma'am, what did you say it was?
I said it was 77.3.
Yeah.
Uh-oh, sorry,
Yeah.
I'm not doing good calculation. Thank you.
77.3. Yeah.
Okay, last question. If frequency input 1 kilohertz, what frequency out? F out.
Same thing.
That's what we already telling you. Same thing.
For the half-wave rectifier, the frequency in and the frequency out is the same.
Exactly. Okay? Now, if you understand that halfway rectifier, that will be help you to understand this one. Okay? That's what we already calculate that. Now, this circuitry. Okay? Now you can see this is they get to diode. However, the transformer different from the one we just know. Okay? You can see this transformer, okay? Different from that one. The thing that they routed right in the middle right here.
Hey, Mr. Pham, just a real quick question.
Yeah,
So on the first one, that's a half-wave rectifier with one diode, and the full-wave rectifier look like you got two diodes.
exactly. However, you can see another difference between two transformers.
Right, that's a center tap on that one.
Right,
That means it's dividing whatever voltage come from the primary to the secondary gets divided in half.
exactly. Okay? Now, when you see this schematic for the transformer, what they call a center tap transformer. What that mean? That mean you get the volt primary. In the secondary, they divide by 2. You see, what here? The DC average, VDC 2 times V peak divide. We don't care that one. However, in here, they say F out equal 2 times V in. Ideal diode 0 volt. Practical 0.7 volt. Okay, now I'm telling you. When you get the V in positive, okay? When you get a V in positive, okay, then basically they divide by 2. Like if you get 120 volt, that's what they call full wave rectified. Okay, first thing we're using center tap. Transformer. Okay. That means the output, the secondary. So the secondary will be divided by 2. Okay. So number 2, I given you example. If the primary equal 60 volt, volt peak, okay, that will be telling you then the secondary. Okay, the secondary, that means from here to here, okay, they will be depending on what you get, the ratio right here. However, in a secondary, they given you half on the top, half on the second, and they already given to you right here, okay? V secondary divided by 2, okay? So if I say V peak equals 60 volt peak, okay, then V secondary divided by 2.
Is 30.
Okay, divide by 2 equal 30 volt. Okay, so basically you get a 30 volt here, you get a 30 volt here. Okay, now see what's going on. Input here positive, you turn on that one. Okay, so basically when you turn on this one, you can get the blue out. Okay, for same thing like halfway. And now when you get a negative here, okay, when you get the negative, that means the red go into the red right here, okay? Then basically the round in the middle here, so you can get the same thing, but positive, and you get, this will be another one, okay? So red go with the diode, red diode, blue go with the blue diode, and the output will be look like. So from here to here, that means the full cycle. And now you can get both. Positive, you get this one. Negative, you get the other one. That's what they call a full wave rectified. That means they rectify positive and also they rectify negative. Okay? Only thing you have to understand in here, they said output, frequency output equal to Q time F in, okay? So basically, if you get a 1 kilohertz at the input here and the output here will be 2 kilohertz. Okay, so when you're looking into the circuitry, you recognize this is the full wave rectifier. They rectify both positive and the negative of the signal input. Okay, and also they're telling you the frequency output will be equal double of the frequency input. If they say input 1 kilohertz, then the frequency output will be 2 kilohertz. Okay, and looking into the transformer, it is routed in the middle here. They what they call a center tap transformer. Okay, and in here they already telling you, you get VP here, mean primary voltage, and the voltage from here to round, or from here to round, equal V secondary divided by 2.
So they'd both be 30 volts,
Yeah,
both sides.
okay.
Hey, Mr. Pham, put an A in your word transformer. Yeah, transformers, TRAN.
Okay. Thank you.
Whoops.
The A-N, right?
There
Yeah.
we go.
Now, there's a picture, a little more detail.
Okay.
Okay, this is still center tap transformer. You get input here, primary. However, the output in here, you see one going to secondary divided by 2. And another one will be secondary divided by 2. Okay, that's what we say. If you get 60 volt peak, then this one will be, okay, 30 volt. And that will be 30 volt. How come that happened? Now,
Because of the center
center tap.
center tap transformer.
Yeah, they divide by 2. Okay, now you see this is a sideways positive. Okay, so this D1 on. Okay, when this positive, this will be negative. So at this D1 on, then this part will be D2 off right here. However, the next cycle here, when they go up here, that means this will be turned D2 on and this will be turned D1 off. Okay, so that's why they given to you. Positive, they turn the blue diode on. Red part, they turn the red diode on. So that's why you get
Only one on at a time.
right. This is a full cycle here. The half first turn this on. The half second turn the two on. So that's why signal will be full wave rectifier. Okay, that's what they already given to you, a little more detail. When you're reading, try to understand. You see that we in here. First part, okay, this will be on. So that's why you can see that's just a halfway, okay? And then when you go to the negative part here, then this will be off and this will be on. That's why I given you the full wave. You see that? Red and blue in here. Turn that D2 on, okay? And D1 off, so that's why you can get this part here. So depending on the input coming in, that's what we call a full wave. Okay, And also, same thing. In here, they've given you a little more detail. First thing, you can see, understand if we pick secondary divided by 2, that means the voltage from here to here. Okay? However, after the diode D1, the voltage will be V pick second divided by 2, but you have to minus 0.7 volt. We already talked to you. Diode will be on. When they on, okay, you substitute the diode by the 0.7 volt. Okay? And that's why you can get the V peak second divided by 2 minus 0.7. And this will be happen the same thing. Okay? That means V peak second here, same thing, V peak second divided by 2 minus 0.7. And finally, the voltage here, V peak out will be equal V peak second divided by 2 minus 0.7. Okay? And okay, so
Hey, Mr. Pham,
yeah,
on that last one, could you go back to just real quick? Okay, on the output, you got V peak divided by 2 minus 0.7, but you got two diodes. So shouldn't that be 1.4?
yeah, that's 0.7 minus 0.7. I don't know if they get any example in here or not.
Because you got the diode on top, and it's V peak divided by 2 minus 0.7. Then you got V peak on the bottom divided by 2 minus 0.7. But 0.7 and 0.7 is 1.4. So then whatever answer you have on the output gets minus 1.4. Is that correct or what? I don't know.
Okay, basically now to see that we pick out. Okay,
Right,
that means they measure from here to ground.
correct.
Okay, so basically either they could be this one or this one, not combined.
Is that because the circuit coming out from that is in the middle?
Yeah, no, not in the middle, but the thing is, when the V out measure in the middle here to the ground, right? So either that one coming out and that one coming out later, you can see, let's
Okay,
see,
okay, I
here,
think I got it. Because it's flipping back and forth.
right, exactly, okay? One for that one, the other one for that one. So you only get,
So you're saying it's one at a time then?
right,
Right.
so that's why you get only minus 0.7.
Okay.
Okay, let's see. That what that try see. For the circuit cell, calculate V peak. Who telling me what V peak equal?
Let's see.
Oh, V peak, so
100.
V peak second.
you got 100 divided by 2 is 50.
50.
Oh, V pick second?
V peak second.
Okay, V pick second would be 50 volts.
Perfect. 50 volts.
Because there's a 2-to-1 ratio, so you just
Exactly.
take the 100 and divide it by 2.
Exactly. You know the V second equal V peak time NS divide NP. Okay? That's why you get 50. Okay? Let's see. So voltage waveform across X half. Here, you see that? They show you V Satan divided by 2.
So 50 divided by 2 is 25. So
I
this
got
half point.
25. Okay?
Mhm.
And now the output will be this one.
So 25 minus 0.7.
Exactly. That's why you get 24.3. Okay, almost. Now same thing. That's what they call a bridge rectifier. They're using 4 diodes. However, the transformer is normal, not center tap. Okay? They don't want to using the center tap transformer. Why? Cost too much.
Oh.
Okay? They do the same job. However, bridge rectifier using only 4 diode. 8 diode, 25 cents.
So
Transformer can be transform. Let's say center tap transformer can be $100.
Oh.
So that's why same signal, but they cheaper.
Got
Okay,
it. Yep.
and
so you say they use the bridge more than the center tap?
right, they're not using center tap. Got too much. Okay, you can say input here, output full way rectify. Rectify both positive and negative, but it's much cheaper. Okay,
Unless you have found money, right?
right. Now, see how they explain to you. Which diode will be on? Which diode will be off? First thing, when the signal is positive, okay, that means you get a positive here, and this will be a negative. If you get a positive here, what diode will be on?
So you're saying that D1 and D2 work together and D3 and D4
Yeah,
work together.
they draw this way, and easy for you to recognize.
Equal
D1
time.
and D2 work
So
together.
so D1 and D2 are forward bias, while D3 and D4 are reverse bias.
Exactly, but the thing I want you to understand now, what I telling you, if you get the input positive, telling me D1, D2, D3, D4, which one will be forward bias?
1 and 2 forward bias.
1 and 2.
Okay, now, first thing, if I say this is 50 volt, then right here 50 volt, right? Is
50
it
volts,
correct?
right?
We're not talking about the value going down depending on the ratio, but I'm talking about positive voltage. If you get 50 volt here,
Where is your mark? Where are you pointing at?
can you see it?
Yeah,
Yes.
I can see it.
Okay, now if I said 50 volt, right here 50 volt, telling me which diode will be on. However, remember, if you get a 50 volt on this side, what on this side? They have to be minor,
Yeah.
50, correct?
Minus, yeah.
The thing is here is not center tap. So this side positive, this side have to be negative. Okay, now if you get positive here, 50, what diode on?
D1 is on, so D2
No,
is on.
talking about D1 first.
Okay,
D1 is on.
D1 is on.
How?
Because you said that the anode was positive, 50 volts.
50 volt here, however, this will be round here.
Right. So that makes the
D1 on. Correct?
D1 is on.
Okay, I agree. What else? How about D2?
D2, let me see. Well, the anode on D2 is going to ground, but you got
It would be on because it would be a positive 0.7 volts, right?
Okay, now, when I talking to you, that 50 volt, for example, what
right.
this side?
Oh, negative 50. Oh, that's right.
Negative 50.
Negative 50.
Right.
This
And
side will be
zero.
0.
Yeah.
And zero is higher than negative 50.
So that D2 on.
So it's on. Yeah, there we go.
Okay? That is explain to you. D1 on and D2 on. Okay? So now they go to a next back here. Okay? And basically, when D1 on, D2 on, the positive signal here going here. Okay? And then this is explained to you for negative part here. If a negative part here, then this is a negative and this will be positive. So D1 on and D2 on. So this is a negative, okay? The thing is this is negative, this is a positive, so that's why you get another part, okay? In here also they're telling you, during a negative half cycle of the input D3, D4 forward bias and conductor current D1 and D2 will be reverse bias. That means this one and this one will be off, and
Right.
this one, the blue one off, and the black one will be on.
So they flip back and forth.
Right. Okay, so basically they're telling you if they on 0.7 volt, on 0.7 volt, and the output here will be equal Vp second minus 1.4, 0.7 plus 0.7, that's a 1.4.
Ooh.
Okay, for the bridge rectified circuit below, transformer is specified 12 volt IMS secondary, voltage for the standard 110 volt across primary. They want to know the peak output voltage. Determine the peak output voltage right here. Okay? I try to see if they calculated for you. Okay? Now,
So V pick is 110 volts. VS is 12 volts.
right. The peak second.
Right.
Okay? That means 12 volt. Now we're going back to the formula they given to you here.
Okay.
Here, V peak out equal V peak secondary minus 1.4.
Okay, what page was that on?
12 volt, right? 12 volt IMF, okay? That's the V peak second. And if you apply the formula
Oh, there it is.
here, V peak out, V peak second, okay? Minus 1.4 volt.
1.6.
However, you have to pay attention on that one. They say they have a 12 volt IMF secondary. That's a VIMF, not V peak. Okay, so basically you get V peak equal the formula V IMF divided by 2.
Okay.
Is it? No. Divide 0.7. Sorry.
VRMS. Okay, what is VRMS?
Ah, let's see.
RMS stands for root mean square. It's
Exactly.
0.707 times the peak.
Exactly.
Oh, okay, on the first page. Got it. Okay.
VIMF equal 0.707 times V peak. Okay?
Yes.
So that's why if you get a V peak, then you take VIMF divide 0.707. Okay? So basically, V peak equal V peak second. Is it right? VP second. Okay? So basically, they have to be equal 12 divide 0.707 equal 16.9. We pick. Okay? And if they want a V out, they're giving you the formula here.
Okay, just so I'm clear on this, the formula is VRMS divided by 0.707. And then you said VRMS is 12. Now, did you get the 12 from the VS?
Right here.
Oh, oh, I'm sorry. Okay.
Okay.
Yeah,
That's a V secondary.
right. Okay.
You want V peak. The thing is the formula will be V peak like V peak out.
You're going to flip-flop the formula around.
Right here. V peak out equal V peak second minus 1.4. That for bridge rectifier. The thing is when you're working on left phone, you should be working on that thing. Okay? Okay, let's see. Capacitor input filter. So basically the capacitor right here. Okay, when you get an input positive, turn on the diode. Okay, the current will be flow charging for VC. They show you at the time at the beginning on VC start 0 and the signal will be charged to the voltage on the capacitor. Okay, and also the diode will be turned on, so that's why you can get 0.7 volt. Okay, minus 0.7. Initially charging of the capacitor, diode a forward bias happen only once when the power is turned on. That means you just turn on the power and the voltage on the capacitor at the beginning is 0. And now they will be charging on the capacitor, the voltage charging up. Okay? You see that? When they charging up to that point, okay? And they will be negative part of that diode here. So that's why capacitor will be discharged. You see that? Going down. Okay? And here, if you're reading it, the capacitor discharge through IL after peak of positive alternation when the diode is reversed bias. That means when I get a negative input here, that means the negative, then the diode will be open. Okay? And now the capacitor will be discharged through the resistor right here. This discharging occurs during the portion of the input voltage indicated by the solid blue curve. Okay? That means this part here, negative capacitor will be discharged. You see that discharge, then that later on, positive discharge again. That's how. Okay? So basically, that will be discharge, then discharge again. Okay? This what they call a ripple. Okay? What is a ripple? We already talked to you. What is a ripple?
Goodness.
That's talking about ripple here. That means the capacitor jack up here, then they discharge. Then they jack up, they discharge. That's what they call a ripple. Again, ripple means the noise. Okay? They want the DC voltage here. They don't want keep go up, go down. Okay? This is an unwanted signal. That means the noise. Okay? Lag ripple means less effective filtering. That means the capacitor jack discharge is not good. Now, you can get better capacitor. They discharge, then they charge again. Okay? Smaller ripple means more effective effective filtering. Generally, the larger the capacitor value, the smaller the ripple for the same input and the load. Okay, that means if you want a less ripple, less noise, okay, you want using the large value of the capacitor.
So the capacitor is responsible for the filter circuit in a power supply or whatever?
Yeah, that means they don't want this noise, ripple, okay? Like, we get the contract with the government to design something, then they have to give it to you, okay? That means they want a ripple how much 0.001 millivolt. Then we have to select the capacitor jack and discharge to get a very, very small ripple, okay? And that's why you can see V secondary, and that will be DC voltage. So the ripple voltage, this is a ripple, okay? When you're working on a left phone, you have to measure the ripple voltage. Basically, that's a very small, okay? Very small voltage. Okay? For a both circuit, they want to know V primary, V peak primary. Okay, now we get this one done, and we can stop. Tell me, what V peak primary? Who can calculate it? Let me know. They given you 115 volt IMS 60 hertz. First thing they want V peak primary.
$115.
How can we get?
Because up above there, up above the capacitor, there's a 10:1. That means
No.
what?
Now they're asking about primary first. Okay, basically they give it to you. V. Okay, V primary, right? V primary. V pick 14. V primary equal 150.
Okay, I'm a little confused on that because
Okay, hold on.
it said RMS, so I just assumed that was
No.
the secondary. For some reason, I thought they were flipped, but they're not.
Okay, they given you a 115 VIMS for VP, right?
Right.
Okay, now they asking VP primary. Okay. You get the VIMS. Now you want V thick. So they will be equal 115 divide right?
Oh boy.
They want V thick. One 62.6. Can you follow that? They given you a VIMS primary. They asking about V peak primary. So you have to converting from VIMS to V peak.
Hey, Mr. Pham, once you do that, don't you have to multiply something times 10 because it's a 10 to 1
No,
rate?
no, not yet, not yet.
Oh, not yet. Okay.
The thing that they asking you, number A, they asking you V peak primary. Right here.
Right. It's 162.6.
0.6. Okay. Now they asking VP secondary. So now you have to do using VP. Okay. Secondary. Equal what?
It's 10 to 1, so 162.6.
You got to take that big number.
162.6 times what? Times 1 divide 10.
Divide by 10.
So basically 16.26, right?
Right.
That will be the peak.
That'll be V peak secondary, right?
Right. That the peak second. And
And
they
what we
said, yeah,
so that's a step down transformer.
that. And the number C, the unfiltered filtered peak full wave rectified. So you have to apply the formula. Okay. Let's see. The formula they given to you up here somewhere. We pick out, okay, let's see, minus 1.4, I think so. Yeah, that means they want the V out right here, output voltage here, okay? So you have to go into uh, rectifier here to get the formula. But finally, what is the frequency output? Input is 60 Hz. What is the output frequency?
60, so what is it, 120?
Can you tell me what the frequency out?
120.
Perfect.
In a halfway rectifier, the input and output is the same. In this one here, in the full wave or bridge, it double.
That's what I want. If you see that, you want to calculate the output, you take the V peak second minus 1.4 volt. Okay? And also, they can tell you. Okay, let's see. I think here somehow they telling you, okay, that means the frequency will be double, right? Output frequency.
So the unfiltered peak wave rectified voltage would be P out equals P secondary minus 1.4.
Exactly.
Okay.
Okay, and the frequency, if the input 60 Hz for the full wave rectified, output will be double. Okay, so you get any question. Next time, we will be start with the transistor. Okay? Try to go through the handout to make sure you're reading it and you're able to follow it. Okay? Like on this type circuit here, we can tell you for positive input, which diode will be on, which diode will be off. Okay? That's talking about a bridge rectifier.
Well, in that situation, they would be flipping back and forth, right?
Right.
Okay.
Okay, and make sure uh, the time right now, we open the class at 2:30 and close at 7:30. 5 hours. And the next week maybe change. The thing is, I have to meeting with the dean. They said the city open 3:30 and close 8:30. Still same 5 hours. However, I move it, earlier 1 hour. 2:30 to 7:30, still 5 hours. The reason is it is not safety in this in the class area. The thing is after 7:30, it's really dark. And we don't have a security like in campus, so that's why I go a little 1 hour earlier.
For security.
Yeah, I appreciate that, and I'm thankful that you guys open earlier. It works better for me. I wake up super early and I have a lot of stuff I have to do, and then I get to the lab, in the middle of the day, and I'm out of there by dinner time. I'm able to come home and take care of my 87-year-old mother. So I'm happy with the way things are.
Yeah, that's normally okay. However, someone confirm or somehow my dean email to me. They talking about class in the campus start 3:30 and close 8:30. How come we open different? That's why next week I have to meeting with the dean. I will telling him before we open up to 9. Okay, PM. The thing is on that time we get a security up there. 9 o'clock he leave it. That's okay to me. However, now no security at all.
Oh,
Okay,
I don't know what you're saying, Mr. Pham. They used to have a security guard here,
right, but not now.
but not now.
Right,
So you want to open early and close
only
earlier because of security purposes.
Yeah, that makes perfect sense to me.
that exactly. Okay, I will be talk to the dean next week meeting. Okay, and I can say, okay, that is why I open earlier 1 hour. The thing is, I feel not safety for my student. Okay, if you want me to open like in the campus, that's okay, it's fine to me. However, anything else happen in that area, I don't care. So I don't think they want me to open like in campus. In campus, they get the security.
Hey,
And we here,
Mr. Pham,
we have.
Mr. Pham, the San Diego Community College District has their own police force.
Exactly.
Isn't their police force responsible for the this campus as well?
Yeah. Otherwise, they have to move it into the campus. That never happened.
No. I'm saying that the community college police, they're responsible for all the
No,
continuing education.
not for this area. Not for my class area.
Well, they probably haven't staffed your class area, but your class is a part of the continuing education thing, so it should be covered.
They not.
That's funny.
Yeah, the thing it look like, I don't know. But the thing is, before it's okay. Now they don't have any security up there. So that's why I don't want. I don't want anything happen to my student.
Thank you.
No money.
Yeah. They're cutting costs, that's for sure, if they're doing that. And this is also, just so everyone knows, this is an extension site. So it's not like a regular
Campus.
continuing education building.
Uh-huh.
It's specialized. It's
Exactly.
yeah. So
They don't know anything about my class, electronic class. They just think, most of the ESLs. Okay? So they don't know anything about my program. So that's why nobody touched me. Okay? They cannot tell me what to do.
So you think, right?
Yeah. You see, I'm running this program for how many years? 40 years.
and you know what? I would love to hear some success stories, because I know there's got to be a lot of them, of people who have got the certificate for electronic technician and are now happy in a job and have a career and everything like that.
Right. I can see that. So that's why I'm thinking for this continuing education. Before I get a lot of students, I supposed to be open the private school to get the money. However, I get enough money for my living, so I don't care. Only free I can take it. Your guy don't have to pay anything.
Hey,
Okay?
Mr. Pham, I got a different question. Because I've been with you for a while. Every now and then I have like a little question to ask. So what's a good date and time for me to contact you?
Monday.
Monday?
Yeah.
Like what hour?
From 2 o'clock up to 7:30.
Okay. Should I do a text mail, email, or Zoom?
No, I cannot. You can talk to me, that's okay. You can
Okay.
text me. Monday I teaching for Tech Two.
Okay. So Monday I can talk to you on the phone?
Yeah.
Okay. And then once again, what hour? Because I don't want to mess up the schedule.
Before 5 o'clock.
Okay, before 5.
So I start teaching Tech Two at 5.
Okay. So maybe like 2:30 or 3 o'clock is a good
No big
time.
deal.
Okay, thank you.
Okay, so good night to everyone.
Okay.
Good
Hey,
night.
Mr. Pham, don't forget to
Thank
get
you.
your iPad fixed.
Yeah, I try to fix the iPad. Okay.
Thank
Okay.
you.
Thank you so much.
Okay.
Thank you, Mr.
We'll see
Pham.
you guys Monday.
Okay, bye-bye.